welcoming Liman to the stage.
So thank you. I'm on the DNS side of Netnod and have been so for a very long time. And I'm going to talk a little about a new project that we are getting ourselves into called Robust DNS and the software that's being created in that project, which is a joint project with other people that you will see in this presentation. So looking at the DNS, what's the problem? The problem that we're looking at is privacy leaks. By querying the DNS, you send your query about something that you want to know or your browser wants to know, and that contains information also with your IP address. So if you look at that query, you can make assumptions about that someone very close to you wants to know something about this, and that's a privacy issue. And that data is often used by the DNS server operator or the resolver operator without much respect to the user's privacy. And also unique DNS queries are starting to be used as replacements for cookies. So that you have a random string that you bake into the web page, and by following that specific query string, you can get information about user behavior in that browser. And that's not covered by the regulations for cookies, so they can do that without asking your permission. And also cybersecurity. The DNS system is used as a synchronization point for instance, evolving botnets. They would use the DNS to find their command and control centers, for instance. And these are things you can look at and analyze at the resolver point in the DNS system if you have enough data. So what can we do? The resolvers, which are the servers that are in direct contact with your client computer, your laptop or your telephone or whatnot, they produce logs, or can be made to produce logs, which can be analyzed, but they do contain privacy-sensitive data. But if you aggregate that data and you process it before you start to analyze it in such a way that you add a certain level of anonymity. And here you get into very detailed discussions about what exactly is anonymity. And we don't pretend that we can go make it totally anonymous. So we're looking for something called pseudonymity. That's a difficult word for me. But that will take away the actual user-sensitive part of the information, and we will only look at the content of the data, because that's in large numbers. That is what gives this intelligence that we are looking for in this project. And from that intelligence, you can generate threat warnings. We see this emerging botnet that is starting to ask queries about certain domain names, and you can use that. From the analysis machinery, you can feed that back to the resolver and tell it that, whoops, this is probably not something you want to give the user access to, because it's either a bot that's doing bad things, or it's a web page containing malware that will infect your computer or something like that. So we believe that we can build a system where aggregated and pseudonymized DNS resolve logs can be analyzed without privacy issues. Well, try to say it yourselves. So we have engaged in this robust DNS project, and the goal is to produce open source software where we have a design for a client part which can perform the DNS resolver function, but also generate pseudonymized, anonymized information to a central analysis function. And then also, of course, and this is something that we hope to be operated in multiple places, and then also software for a central analysis center that can do the actual analysis and produce the feedback that's needed to the resolvers. That was not the right, use this one instead. So this is the overview picture. We are looking at producing edge software that does the resolver and feeds back into the core system that does the analysis and sends feedback to the edge systems, but also possibly to other third-party players that can make use of this information. For instance, you could look at the CERT or emergency response teams that need or want information about emerging threats on the network and so on. Now, the next picture I'm going to show you is what a normal presenter would have showed you, which is a totally unreadable picture. So that's not me, this is me. So this is the entire design, and it looks a bit complicated. Let's see if this has a laser pointer. Does it? No, I don't think it does. So I'll slowly move over here. So it all starts over here with the client sending its queries to the resolver function. And from the resolver, we hope to be able to get these logs out to a minimizer. And here is where we try to remove all the user-sensitive information. Now, there are some types of resolvers excuse me, that don't produce these logs in a way that we would like to. So in that case, you can put a proxy machine just to generate the logs in front of the resolver. So there are two options there for how to operate this. And this piece will then send information to an event receiver in the central system, which is the upper part, but also some types of information needs to be aggregated over a period of time before you send it back. So we have to have a feature store and an aggregate feed, and both these feed back into databases in the central system, and an analyzer function that feeds back into the databases. From the analysis, we get events back to a feeder that sends intelligence to management software at the edge that can feed back into the resolver and say, this is probably things that you don't want to resolve. This is dangerous stuff. And it will also feed back into the minimizer and other places. And the feeder can also send configuration to the minimizer to behave differently, save different types of packets, ignore certain packets, analyzing that, saying that this is all good, you don't have to worry about that one. So there are feedback loops in this entire system. And of course, also the possibility for third parties to receive this intelligence if they want to. So this project has started. We are working on a design. Software is being written, especially for the analysis part, but also for the feeding part on how to feed the analyzer with the packet data. And we hope to finish a proof of concept model this year. We have to kind of restart next year with the next steps and set up a cloud service for development and testing, and hopefully start to talk to early adopters that are willing to help us to polish the model and the software to get it into a good working state. To discuss with the various service providers, we hope to be able to reach out to service providers to help us to feed the data, so that we can rely on information from the resolvers already being operated by putting these anonymizer and feedback system into their systems, and of course feeding back to their resolvers the results of the analysis. And of course, find a long-term solution for financing this project, both the open source project and the analysis part, which has to be ongoing. So we are now in phase 1 of this. We have money for 2023 to finish the proof of concept implementation, and we hope to continue to build on that in 2024. And then in phase 3, which is probably two or 3 years down the line, to find a situation where we have normal operation and things turning as we would like to see them in the future. The people involved in this, we have main funding from Post- och telestyrelsen, the National Telecommunications Agency, and we also have resources from SUNET, the Swedish University Network, Internetstiftelsen.se, and Netnod, and we also have a group of select partners, mostly technical experts, that help us with the various pieces in the project and to analyze and design and write the software for that. So that's what I intended to talk about. If there are any questions, I'll be happy to try to answer and toss it over to other people. A few of my friends are in the group, in the audience here.
Well, we have time maybe for one quick question. Anyone in the audience? Yes.
Does it work?
Yes.
Yeah. Hi, Elias is my name. I work at Bahnhof. I was just wondering, could you mention a specific example of a threat that this could have worked against?
That this could have worked against? No, not a specific threat, a specific thing, but you can imagine growing botnets where you can see how the bots that are starting to be deployed actually do query for a specific domain name, and if you can follow that domain name and see how these things roll out, you're able to mitigate the impact of that botnet, feeding back to the actors who can actually do something about it. Yep, thanks.
Okay, for purposes of time, I think we should move straight on to the next presentation.